today what we want to do, guys, is we want to look at solving radical equations. So, to solve a radical equation, it's an equation that contains a radical or rational exponent. You need to eliminate the radical or rational exponent and obtain a polynomial equation. The key is to raise each side of the equation to the same power. So what that means is that if I have this equation a equals b, then what I want to do is I want to raise both sides to the same power. Like here, I raised it to the n, both sides to the n. Then solve the new equation using standard procedures. We talked about solving polynomial equations. Before raising each side of an equation to the same power, you should isolate the radical expression on one side of the equation. This is key right here, that we need to isolate, if possible, the radical expression on one side of the equation. That means get it by itself. Now there's one term that we need to talk about, because sometimes when we solve radical equations or other equations that we're going to talk about for the rest of the year, is there's this thing called an extraneous solution. So an extraneous solution is a solution of an equation that is not a valid solution of the original equation. So what that means is that if I were to plug something into my equation, I got it when I worked all the stuff out, it worked out perfectly, but when I plug it back into the equation, it doesn't work. So what I want to do is just go over some simple examples, and we'll go from there. So looking at this equation, this is just a simple radical expression. So I want to solve for x, and I want to check for extraneous solutions. When I look at this, remember the key thing that we talked about is that we want to isolate the radical expression on one side of the equation. This is the key thing right here. So when I look at this question, this is my radical expression, okay? The cube root of x. So what I want to do is I'm going to add 4 to both sides. So on the right, I have 1, and I have the cube root of x. So what do I want to do next is I want to get rid of the cube root. What gets rid of a cube root? Well, it's taking both sides to the third power. So I end up with x equaling 1. So if I check it, because I want to get in the habit of checking it, so if I'm taking the cube root of 1 minus 4, it should equal negative 3. So the cube root of 1 is 1 minus 4 does equal negative 3. So that checks out. So let's look at another example. So here's my radical expression, the square root of x plus 6. So remember, the key is for me to isolate that. So that means I want to get this quantity by itself. So the first thing I want to do is I'm not going to divide everything by 3, because division is usually the last thing I want to do when I want to solve an equation. I want to subtract the 5 from both sides. So I got 3 times the square root of x plus 6, and that's going to equal 9. Now I still want to get the square root of x plus 6 by itself, so I'm going to divide both sides by 3. So right now I have the square root of x plus 6 equals 3. So I want to get the x plus 6 by itself, so the way I do that is square both sides. So I get x plus 6 equals 9. So next, I want to get x by itself, so I'm going to subtract 6 from both sides. So I get x to equal 3. So let's check to see if it works. So I'm doing 3 times the square root of 3 plus 6 plus 5. And that should equal 14. So let's see. I got 3 times the square root of 9 plus 5. So that's 3 times 3 plus 5. That's 9 plus 5, which equals 14. So that checks out. Okay. So try the next 2 examples. And what I want to do is jump to example 2 and just look at some example 2 questions. So in this case, this is my rational exponent. This is what I want to get by itself. So I'm going to subtract 7 from both sides. So I have 2 times x to the 3/4 equals 16. I'm going to divide both sides by 2. So I have x to the 3/4 equals 8. So now what I want to do is I want to get rid of the 3/4. So what I'm going to do is take both sides to the reciprocal of this power. So the reciprocal of 3/4 is 4/3. So I'm going to do that to both sides. So right now, I know x equals 8 to the 4/3 power. Now, one of the things that we want to get used to is not just plugging into the calculator, because sometimes we have an issue when we do that. So if I look at this, remember we talked about every rational exponent can be rewritten as a root. So this root would be the 3rd root of 8 to the 4th power. So the 3rd root of 8 is 2 to the 4th power. X will equal 16. So if I check it, it should work out. So if I take 2 times 16 to the 3/4 power plus 7, it should equal 23. So that's 2 times the 4th root of 16 cubed plus 7. Well, that's going to be 2 times 2 to the 3rd plus 7. So that's 2 times 8 plus 7. So that's 16 plus 7, which equals 23. So that checks out. Let's do one more. So we're going to look at this. I want to get this by itself first. So I'm going to divide both sides by 2. So I have x plus 1 to the 3/2 power, and that should equal 27. So I'm going to take both sides to the 2/3. So I got x plus 1 equals the 3rd root of 27 to the 2nd power. So that's 3 squared, which is 9. X plus 1 equals 9, so x is 8. So I'm doing 2 times 8 plus 1 to the 3/2 should equal 54. So that's 2 times 9 to the 3/2 should equal 54. So that's 2 times the square root of 9 to the 3rd. So that's 2 times 3 to the 3rd. So that's 2 times 27, which equals 54. So I have a couple examples I want you to do. We'll go over those tomorrow, and see you later.